In this video, we'll be looking at part of problem number 5.44. 5.44 is just dealing with conditional probability. Specifically, we have a two-way table. And our table is displaying a sample of 311 people, it says, and it's looking at their gender and whether or not they own a hybrid or not a hybrid. It says that there are 77 men who own hybrids in this sample, and 117 of these men do not own hybrids. 34 women and 34 women own hybrids and 83 women do not own hybrids. One important note about these two-way tables is that none of these cells are mutually exclusive. That is, nobody can appear in two of them. We're assuming, I suppose, that you only own one vehicle. Okay. The first thing we're going to look at are what's called the marginal distributions. In the margins, we're going to write the totals here. That is, I'm going to add my total number of males, and it's going to come in this cell right here. So 77 and 117 is a total of 194. This number is the total number of males. 34 plus 84, that is 118. That's the total number of females. And now look at these totals. 77 plus 34 is 111. This is the total hybrids. And then not hybrids, 117 over 80, 117 plus 84, that appears to be 201. Now, this here, this is my total. It is the total number of people. This should be, it says 311. I'm getting 312. What's my each of 300 people who purchased a Honda Civic? So they just made a small mistake in their addition. Both of these add up to 312. So that is my total number of people in this sample. Okay, so let's look at, I'm going to look at a couple of these. All right, number one says, what is the probability of male? Okay, well, the probability of male is simply the total number of males, which is 194, over the total in my table, 312. And 194 divided by 312 is approximately 0.62. 62%. So we have more men than women. So 38, if there's 62% men, there's going to be 38 or 0.38 women. All right, I'm skipping on down and I'm going to look at this number 3. Number 3 says, what is the probability of a hybrid given that you are male? Okay, first of all, if you have not watched the first video on conditional probability, you should do so at this time to understand what this notation means. But what we're saying is, this is telling us our entire world. Now we're just considering males. We don't even care about the females. Of the males, for the males, there are 194. Of those, how many have hybrids? Well, it is 77. All right, and so this is the probability of having a hybrid given you are male. You can think of this as a little bit like a fraction, and so this would be the denominator. All right, in this case, our whole world are the males, this 194. Okay, so 77 divided 194, that is 0.396, or roughly 0.4 0. So 40% of the males drive hybrids. That means 60% of the males would drive the not hybrids. I'm going to now show this. You can see how easy it was just to, when using the two-way table, you can easily calculate this conditional probabilities. I'm going to show this using the notation from the previous video. In the previous video, we learned that the probability of A given B was equal to the probability of the intersection A and B divided by the probability of B. Okay, so in our case here, the probability, I'm just going to use H for hybrid and M for male. The probability of hybrid given male is equal to the intersection, the probability of hybrid intersect male, divided by, here, the probability of male. Okay, now I'm going to show that we're going to arrive at this same value here. What is the probability of male? Well, we already knew that. The probability of male was 194 over 312. That's going to be my denominator. The probability of male is 194 over 312. Okay. I'm going to put this in parentheses because we're going to get this compound fraction and I want to see what we got going on. The probability of male is this. What's the probability of hybrid and male? Okay. Well, we call this intersection. If you look at where hybrid and male intersect, where hybrid and male intersect, that's 77. Okay, 77 out of my total 312. Hybrid intersect male is 77 over 312. The number of people that are hybrid drivers and male, 77 out of 312. Alright, so it's this fraction divided by this fraction. Hopefully you remember from arithmetic, when you divide by fractions, to say 77 divide 312 divided by 194 over 312. Well, what we do is we invert this second one. This statement here is equal to 77 over 312 times, flip this one over, 312 over 194. So here you see the 312 divides with the 312 to leave 77 over 194. And that is what I yield right here. Okay, so I'm showing this again. You need to watch the previous video that shows this definition, probability of A given B. We had this definition. I'm not throwing the definition away. The definition still works. It's just that when we have this two-way table, it's very easy to answer these questions. This is saying the probability of having a hybrid given you are male. In this case, consider the males as your whole world. That is, this column here is our whole world. Of these 194, that's my denominator, 77 of those have a hybrid. Alright, with this video you should be able to handle the rest of 5.44.